Hello and welcome to G Fun Facts Online. Today, we're heading to one of the most remote and extreme places on Earth, the Arctic. But we're not just going for the scenery. We're gonna solve a mystery. For decades, scientists have been staring at a climate puzzle, with massive implications for us all. The Earth's northernmost region is warming up at a terrifying pace, 3 to 4 times faster than the rest of the planet. This phenomenon is called Arctic amplification. And for a long time, our best climate models couldn't fully explain why it was happening so fast. What were we missing? Well, recent discoveries have pointed to a surprising culprit, one that's been hiding in plain sight: the clouds. Now, when you think of clouds, you probably think of shade on a sunny day. And in the Arctic summer, with its 24-hour sunlight, you'd be right. The most common clouds there, a delicate mix of ice and supercooled water, called mixed-phase clouds, act like a giant parasol, reflecting sunlight back into space and cooling the surface. But then comes the long, dark Arctic winter. The sun disappears for months, and these same clouds undergo a dramatic personality change. With no sunlight to reflect, they transform into a thermal blanket. They trap the heat radiating up from the Earth's surface and bounce it right back down, warming the region. So how good is this blanket? Well, that's the million-dollar question. The effectiveness of this cloud blanket depends on its ingredients. The more liquid water a cloud contains, the better it is at trapping heat. And this is where our best climate models have been making a critical mistake. A groundbreaking study from Kyushu University compared decades of satellite data with 30 of the world's leading climate models. The results were startling. A whopping 21 of those 30 models got the recipe wrong. They consistently overestimated the amount of ice in these wintertime clouds and underestimated the amount of liquid water. This means for years, our models have been seeing a thin, patchy blanket, when in reality, the Arctic is covered by a much thicker, warmer duvet. They've been systematically understating the warming effect of these clouds, which helps explain why the real-world warming has been outpacing their predictions. Okay, so the models underestimated current warming. Simple enough. But here's where it gets truly weird. This same error has likely caused many of those models to overestimate how much the Arctic will warm in the future. It sounds like a paradox, right? Here's how it works. As the Arctic gets warmer, scientists expect these clouds to hold even more liquid water, making the blanket even more effective. This creates a feedback loop. Warming leads to more liquid in clouds, which leads to more warming. But there's a limit. Once a cloud becomes supersaturated with liquid, adding more doesn't really increase its warming effect much. Because the model started with clouds that were too icy, they assumed there was a huge potential for this feedback loop to ramp up in the future. They predicted a massive shift from ice to liquid. But in reality, the clouds are already quite liquid-rich, so that future warming boost won't be as dramatic as the faulty models predicted. Correcting this one error gives us a more realistic and slightly less extreme projection for the long-term future. So a cloudy forecast for the North Pole. Why should you care? Because what happens in the Arctic doesn't stay in the Arctic. The climate up north is a major driver of weather patterns across the globe. Flawed models don't just get the polar temperature wrong. They can lead to inaccurate forecasts for extreme weather in your backyard, whether you live in North America, Europe, or Asia. A warmer Arctic can warp the jet stream, leading to those stubborn heat waves, brutal cold snaps, and massive storms we've been seeing more of. And the consequences are already piling up. The Greenland ice sheet is melting at an alarming rate, pouring water into the ocean and pushing sea levels higher, threatening coastal cities everywhere. And then there's the permafrost, the permanently frozen ground. As it thaws, it's starting to release vast quantities of stored carbon dioxide and methane, adding yet another feedback loop to global warming. It's a genuine ticking time bomb. This discovery about the true nature of winter clouds is a huge step forward in solving the puzzle of Arctic amplification. By finding this ice bias in our models, scientists can now refine them, giving us a much clearer picture of our planet's present and future. It's a powerful reminder that in the incredibly complex machine that is our climate, understanding the tiniest details, like the ratio of ice to water in a single cloud, can have world-altering consequences. The science is getting clearer. The challenge now is to turn that clarity into decisive action.